Please help me in welcoming our next speaker, Riccardo Tempesta, CTO at Mage Specialist. He will be telling us how awesome Magento 2.3 architecture are. Round of applause for it.
Good morning. So, pretty excited to be here again. It's always nice to see how many people are at MageCONF, but actually this year is super amazing. I can feel the net and even the power that is going. Okay, it's working. So today we are going to talk about the awesome architectures in Magento 2.3, a true story. But before we go, just allow me to introduce myself, just in case you never heard about me. My name is Riccardo Tempesta. I am CTO at Mage Specialist. I was one of the top 5 contributors in 2018. I'm a Magento community maintainer, Magento master for 2019, and proud father of Julia since 2019. That is probably the most amazing part. But most of the people know me under a different name, that is the Rick. And that is my actual picture. Don't believe to people that say that I use Photoshop. That is my real shape. It's just because my shirt is very, constrictive. Yeah. So, a disclaimer. So the next slides may contain a personal interpretation that may differ from the official Magento architect's position. I mean, I'm not a Magento employee, so you will not see anything that is official here, not official roadmap. It's just my idea of the future of Magento and the personal interpretation on where Magento is going. It's just a disclaimer to make sure you understand that I'm not an official speaker of Magento. So why the speech? Because honestly, I think that today there is a huge confusion behind Magento. Well, actually, yeah, because sometimes it's very stressful, to go from Magento 1 to Magento 2 because this new word seems quite confusing. But sometimes it even depends on your seniority, if you're junior developer, senior developer, or if you're coming from Magento 1 or you started from Magento 2. Because, for example, I have this junior guy in my company. He's a very nice developer that always is just 23. He's a very nice guy, and he's always telling me that being a Magento developer is not stressful at all. Absolutely. Yeah, of course, this is a joke. You can imagine because he is not 23. He's just 20. You can understand. So, but anyway, why? So this is just a joke, of course, but where this confusion comes from? Before understanding where the confusion comes from, let me show you something. So confusion comes from a Latin verb that is confundere, that is the union of two words, that is cum plus fundere, that means to merge together. What does it mean? When you have confusion, basically, you cannot distinguish anymore which part belongs to what. So when you meld together two objects, two knowledge, basically you get one new object as if it's a mixture of them. You cannot distinguish anymore which part was belonging to what part. This is actually confusion because what is happening today is that we are stuck at the Magento 1 way, even if we are Magento 2 developers. Most of the people are still using the same approach as they had in Magento 1. This is where confusion comes from, because basically you're using Magento 2 as you were using Magento 1. So my idea is to try to explain you some of the architectural ideas behind to move you away from confusion, because despite the negative meaning of the term confusion we usually give, confusion is a nice state because after confusion you create something new. But of course you have to move away from this state, otherwise it will just remain a mixture of something you have no idea what. Because in the meanwhile, there were a lot of things coming in Magento 2. Stranger things. But to let you understand where Magento is now and where Magento is going, I need to let you understand one, well, actually, I will tell you a secret, that Magento is a complex platform. Did you know? Oh. Okay, great. So let's talk about software complexity, because you have to understand that architectural decisions are a direct consequence of the software complexity. So this is the development process. I think you know how to develop something. So basically, we got a developer that writes code, that gets compiled or interpreted or whatever, then it got executed. This is not a secret, I think. So basically, when your complexity grows in the software, it is not a problem on this side. Because actually, machines can just compute your code. Maybe they will do it in a slower way, but you can buy a more powerful processor or whatever you like. So basically, that is not the real problem. The real problems come here, because we got a high cognitive load when the software complexity raises. Because what happened? When it grows, you spend the 95% of the time trying to understand what you had in mind 1 year ago when you were writing that piece of crap of code you're looking today. Because does it happen to you, for example, to see what you wrote the year before and think you were drunk while you were coding it? That is evolution, actually. But this always happens. And when you spend most of the time trying to understand what you were trying to do and how to modify the existing code, you can just spend 5% of your time in writing or thinking new features. So basically, we became the real bottleneck. How can we avoid this process? How we can optimize it? It's quite simple. We can add structures, we can raise abstraction, we can reduce the so-called cognitive load. And how can we do? It's quite easy. We all know these methods because you got function, methods, classes, modules, application, and whatever. So the interaction between all those parts is what is called actually architecture. And let's see how architecture was evolved since the first 90s. And ta-da, I will do like every legit Italian should do, talking about pasta. So I will explain to you later why, but this is so in the 90s, we got what we call spaghetti coding era. That is also known as the copy and paste era. So basically, I will explain to you later why it's called spaghetti coding, so just have some fun with the past evolution. So in the 2000s, we got the lasagna coding, also known as the layer monolith. You know, lasagna is made of slices with not slices inside, but it's a huge block. Then we come nowadays with the so-called ravioli coding. Don't ask me what will be in the next time, probably pizza coding, I have no idea. I will check. I can tell you in 10 years. So why? Spaghetti coding era. Why it's called spaghetti? It's quite simple. Because you remember at that time, computer science, because it was not even IT, it was computer science. It was something that was almost black magic because you got a nice UI and a black box working somehow, no one knew what. But if you go and look what is inside the box, actually, this was the condition. This was the condition. So basically, the code was banded together with the code itself. If you remember, at that time was mostly linear programming. So at that time, you got goto, gosub, and that kind of instructions that were messy because you were touching something, you were breaking something else. It's like, you know, why spaghetti? Because if you pull a spaghetti from one side, you break pasta from the other side. So this is why it's called spaghetti coding. So it was no architecture at all. It was very cheap to develop at the very beginning because you don't have to think of what you have to do. You just start writing the code. But of course, you got an evolution limit, and it brings you to a very high cognitive load. It was almost impossible to maintain. This is why lasagna coding comes to us. So basically, lasagna coding, differently from spaghetti coding, is, let's say, it's a nice way to develop something. I mean, at least you have to think before start coding. So lasagna coding means that every upper layer depends on the underneath layer. Because if you imagine lasagna, you cannot pull something from the bottom of lasagna because otherwise everything will collapse. The typical example is a web application. You got HTML, you got PHP, you got database. So you cannot say, for example, I want just to deploy the HTML without PHP or database. It does not make any sense. In Magento, for example, you got controllers, model, resource model, and so on. You cannot say, I want just one part of it. So it's a layered approach to the software. So basically, it is what is called horizontal approach. So basically, if you have multiple feature like, yeah, this is just, of course, an example, customer catalog code, whatever you want. Every Apple layer must be relying on the underneath layer. And this is quite nice from this part because, yeah, it is working. It is more powerful than spaghetti. You can touch something without breaking something else. It seems to be a nice solution. But the problems come when you have to connect the functionalities of all the modules, because you get modules, but not modularity. So you cannot say, for example, I want to remove the catalog. Can you imagine today you uninstall the catalog modules from Magento? I think it can lead to a universe collapse, maybe that kind of, problem with the quantum physics, probably. So this is why it's called layer monolith, because actually this becomes a huge monolith that is more easier to maintain, probably, but it's not easier. It is not easy to split across different parts. So this is why it's called lasagna coding. It becomes a very huge monolith. You also have a lot of drawbacks. So, for example, you cannot scale each layer independently, for example. So if you look at Magento today, for example, if you want to upgrade Magento, you cannot say, I want just to upgrade the catalog. You have to upgrade the whole Magento system. As I told you before, basically you get modules and not modularity. This brings us to the Ravioli coding era. It's called Ravioli because, Ravioli is a kind of pasta in which you have the small pieces, or I'm starting becoming hungry now. All these small pieces that are almost independent each other with something nice inside. No one cares what is inside, it's just tasty. So this is actually what is usually called micro or services or whatever. So basically, the final application is a composition of multiple small features. And this is amazing because you can take each component and deploy it separately. You can scale each component independently. It's super nice. So now the question is, where is Magento now? This brings us to the chapter number 3, the Magento. In this evolution, Magento 1, 2, 2.2, 2.1 and 2.2 probably was here at the lasagna coding. But something changed in Magento 3. We cannot say it's still Ravioli because it's still in the process, but it's something in the middle. Don't ask me what kind of pasta is, I have no idea. Why? Because something changed in Magento 2.3 after one of the most advanced community projects was introduced, the MSI. And if you were here last year, I was speaking about some. How many of you were here at my speech last year? Oh, this is super nice. And if you were here, you know that I'm basically in love with MSI. So what changed? Actually, it was introduced a new idea of how to develop with Magento. And we have to thank, I think, a lot of guys, of course, but I want to mention 2 of them. That is Igor Minailo, my personal hero, and Eugene Shak. Eugene. I'm sorry, I have problems with last names. So they bring to Magento a new idea. Well, actually, it was an existing idea, but bringing to Magento was actually a new idea. That is the service isolation. I will explain you what is my understanding of the Magento service isolation. So you remember before I told you, if we got this horizontal approach, it's nice, but it became messy when you have to connect all the modules together. So basically, we have to stop thinking the software in an horizontal way. We have to switch, to rotate, and think in a vertical way. And you say, yes, it's nice, but you still have connection problem between the modules. So what does it change, honestly? It changes that you should split, for example, your module in this way. So if you split your module or functional area in one API part and one concrete part, let's say the implementation itself, something can change. I will explain you exactly how. So basically, in the API module, we just define what is the abstraction of the functional area or the module. Then we got the implementation. But following the principle of the dependency inversion, The implementation should be depending, of course, on the abstraction, not vice versa, otherwise it's not abstraction anymore. And when you need to connect modules together, you basically allow the connection between modules only through the abstraction. It's like, if you ever heard about the solid principles, it's like the dependency inversion brought to a functional area level. So when you follow this principle, you basically follow the API first way. API first way basically means that you, before, write the API, so the abstraction of your module, then you make the concrete implementation. That actually is another way to say, think before coding. Because sometimes, as a developer, we start coding without thinking exactly how to organize our code. But in this way, you focus more on the functionalities of your module, or your functional area, or whatever you like to call it. Then you implement it. And if you follow this approach, basically, I'm sorry, if you have a module connecting your module, should be passing through API. Then you are passing from modules to modularity, because you can remove one concrete implementation and replace with another implementation without breaking anything. This is, how interface work, of course. This is, for example, an example coming from MSI. This is one API module we got in the MSI, that is the Inventory Catalog API. And as you can see, if you remove, of course, what is the legacy code of Magento, like module catalog, that is honestly a big mud of code today, you got dependency only on API modules. This is the way you should be doing. Because before I heard a very clever question about, is the community ready to embrace, for example, CQRS and all this new approach? Well, I think that if Magento is evolving, honestly should be evolving together with the community, and the community should be aware about these new approaches. I know that it requires some mind shift and mind change, but I think that every mind shift is a condition to an evolution. Otherwise, we cannot think to evolve a product being stuck to an old logic. So this brings to one small parenthesis about the immutable DTOs. You probably heard about what is a DTO. Raise your hand if you did. What is a DTO? Do you know what is a DTO? OK, nice. So basically, DTO stands for Data Transport Object. So today, you're used to if you're a Magento developer, you know you got, for example, models. So if you have a product, you have the model of product. That is a kind of data model of the product. So it's containing all the information of a product. But it has a lot of problems because it's mixing some business logic inside data logic. So it's quite messy today. A data transport object is just, let's say, I'm simplifying the concept, but imagine just a class with some getters and setters inside. So just to put some data inside and send this object somewhere else. So it's an object basically you can serialize without any side effect. Why DTOs are important, for example, in service isolation, and especially immutable DTOs? Because Anton Krill before said something that is very important, that is the unidirectionality of the data. So basically, the data flow should be unidirectional, should not be coming back. And when you use, for example, immutable DTOs, and you send something from module A to module B, if you think that can be totally isolated, this transmission should be immutable. Because if you change something in the module B, it is not reflected, of course, in the module A, in this information. So this is why, from my perspective, using immutable DTO for communication between modules is something very important. Because it's like, when you contact something using an API, when you send this packet, if you change from the previous position, it cannot change on the second position unless you send it again, of course. I did a contribution. I think it's quite nice, just because I did this contribution, so I think it's amazing, about immutable DTO. If you want to have a look, of course, it's just a proposal to the architectural team. It got a concrete implementation that I finished yesterday during the contribution day, the most amazing contribution day ever, probably. And actually, it's a system providing you the ability to quickly define what is a DTO and immutable DTO, if you want to have a look. And I have two say a special thanks to Eugene Sentiabov for supporting me in this operation. He's a Magento 2 architect, very nice guy. I think should be, he's here. I cannot see him. Yeah, it's there. If you have time, speak with him. He's a very smart guy. He didn't pay me to say this. I mean, he didn't pay enough to say this. So, another point, talking about unidirectionality of the data, seen from another perspective, is the circular dependencies. Because when you evolve your architecture, one of the keywords is one direction only. And of course, circular dependencies are not one direction, because they're coming back to the origin, of course. So we said we want modules plus modularity. But what happened, for example, when you got the inventory in Magento, you got the sales from the other side, and you need something that is modifying each other, because of course inventory needs to know something about sales and vice versa. So apparently they are mutually dependent. And this is of course what we want to avoid. Because we should be able to, for example, uninstall or replace a module. Today, as again, it's like talking about a sci-fi movie when you say, I want to remove the inventory, the sales, or the catalog from Magento. But I think that Magento is going in that direction, to have a full modularity. This is my perception. So basically what happened? You should be applying what is called a decoupled dependency. So basically you create one module in the middle that is called inventory sales that, allow me to say, I'm simplifying, of course, again, it's a kind of adapter between inventory and sales. So basically in this module, you pluginize, so you use the plugin system of Magento to modify what you need in inventory and sales. So basically if your system has inventory and you want to install sales, you need even this module and vice versa. If you want to install one of the two components, you install even inventory sales. And everything becomes very modular and independent. To achieve this, of course, you know, if you deal with preferences, you deal with plugin, and so on, basically you need to have a smaller class approach. So basically today, in Magento, you have huge classes with thousands of methods. It's quite a mess if you need to understand what class is doing what. So basically, what you should follow is the single responsibility principle, because this is the only way to understand which class you have to pluginize, which class you have to replace, or whatever. So talking about, again, the solid principles, the S of the solid principle is the single responsibility. And today, Magento has a lot of classes with thousands of responsibilities. So basically, you got the old giant Magento 1 helper. Do you remember? Because helpers were that kind of classes you were putting something in when you didn't know where to put, actually. So I don't know what this is. It's a helper. It's fine. So basically, you should forget that approach and split that huge class of something in smaller classes. This is the single responsibility. And the key of single responsibility is that when you name a class, the name of the class should be enough to understand exactly what the class is doing without reading comments or whatever. So this is why, for example, this is a specific type of single responsibility, because the single responsibility of this class is an action. So when it happens and you get one action, usually you should have one single public method, because if you have an action, it's just one action. You don't need to have multiple public methods. You can have, of course, private methods and so on. But if, for example, the responsibility is an action, from my point of view, the name of the class should start with a verb like this. So get products ideas by SKU. You can understand immediately what this class does. So it's quite simple. It is not, for example, a product management interface. You have no idea what is inside. So when you have problems understanding what is the class name you should give to the specific class, there is probably something wrong behind. This brings us to composition over inheritance. Anton Krill was introducing this before. So it is said that Magento 2 doesn't like inheritance. From my perspective, inheritance is not a sin. You can use when you really need to use it. Because most of the time, inheritance was used for code reusability. So basically, you were extending one class just because you didn't want to write again the code that was in that class. You were composing functionalities of different class. This is the bad way to use inheritance. So Magento 2 decided to switch to composition of inheritance. So basically what you were doing in Magento 1, like class A extends B, class B extends C, and so on, becomes class A with B and C injected inside using the I. This is why you should be avoiding that approach. So this brings us to chapter 5 that is called the module Gadem. Because if you're splitting with all this amount of modules, basically, if you look at the Magento inventory, you got more than 40 modules just for the inventory. This is the first reaction. If you manage to handle panic, you can go to the next level, that is the near data experience. But if you look deeper, and I say again, if you apply this mind shift from the old way to the new way, you become a Lightnet. Because you understand that basically you have fully modular system, you have full service isolation, you got clear code writings, thanks God. Because I think that one of the most difficult parts today in Magento is trying to understand where something happens inside the code. It's amazing. If you work with MSI, it is the Magento you would like to work with, honestly. And it's easy to handle in a structured teamwork. This is very important. And you will have no more God modules, like, for example, catalog. We forgot something, the database. Because now what we built is a kind of, someone called this the Monolith. So basically, you got some microservices or services together, but you have one single failure point that is the database, because everyone is connecting to this database. For example, today, if you try to scale Magento, you replicate Magento, different front end of Magento, one single database. So it is not easy. So we should even follow the database isolation. This means that in our segmentation of Magento, we should think that our persistence can be in different nodes, so even physically separated. So this should not happen anymore. So for example, if you have one foreign key across different functional areas, of course you cannot have multiple databases handling the same operation. This is quite simple to understand, because you cannot have foreign keys across different databases. Unless, of course, you're in a cluster, but technically that is one database. So you should avoid this and move to another approach that is, for example, not using a database consistency, but using an application consistency, and switch to business or natural keys. So no more product ID, use the SKU, for example. This is what is happening, for example, in the MSI project as well. This brings us to the CAP theorem. Raise your hand if you ever heard about the CAP theorem. Super nice. So the CAP theorem is this. In every database system, you have to deal with consistency, availability, and partitioning. Consistency, of course, is what you probably know. Availability is if the data is immediately available, and partitioning is if the data should be split across different sources. And the CAP theorem says that you can only pick 2 of them in one time. So you cannot have all of them. So we are dealing with an e-commerce system, and we want to follow the module isolation. So partitioning is required. Availability should be available. Otherwise, we cannot say, hey, wait, you have to wait 1 minute before buying this product. This is, of course, something unacceptable. So we have to remove consistency. This is very scary at the very beginning, because you say, hey, come on, do you really want to remove consistency from database? Yes. I mean, you should think in another way. First is the vendor consistency, but I want to talk before about this. So this is the old approach. So if we had consistency, remember, it was the crude model. So basically, in the crude model, if you write the data and you read the data, immediately after, you got the data that is perfectly consistent to what you wrote. So a typical example of the PHP Plantation was this one. So you were saving something, and you were returning the ID of the newly saved entity, for example. This is a very typical example. So that is written to database, and immediately you get back something from the database, and it is fully consistent. So basically, this is the flow of the data, and this is not unidirectional, because it's a kind of bidirectional model, because you write and read immediately. If we have multiple systems, the scenario is slightly different, because you can write data from one application to one persistence and read the data from another application from another persistence. And they can be connected together through internet with a latency. So actually what you read can be outdated. So you cannot anymore write something and get ID, for example. So consider switching to CQS. CQS stands for Command and Query Separation. So a command should never return a value. A command is something that writes the persistence. So you put something in a database, you create a file or whatever you want to call. A query should only read from the database and never change the persistency or the application state. This is very important. So your save methods become something like this. Save should not return anything. So I know this is very confusing at the very first time, because you say, okay, but I created a new object, how can I reference this after? I don't have its ID. This is why you should be using, for example, business keys, like SKU, because you wrote in the persistence and you use it as a reference. An evolution, it is not exactly an evolution, but another way to see CQS is to use CQRS. CQRS is another level of abstraction. So basically, it stands for Command and Query Responsibility Segregation. It means basically that when you write something, you can write with a different representation and read with another representation in different parts. Because I don't want to talk about DDD, because otherwise it will take so much time, but CQRS is strictly connected to DDD, in which you can think one module with a dynamics that is totally different from the other module. This is an example in the MSI, just to clarify what I mean. So you write quantity in one persistence, a reservation in one persistence, so they have two different representations of the data, and you write what is the sellable quantity. So basically, you write with one representation, and you read with a different representation. Okay, another part is that if you remove the consistency, you cannot deal with transactions, of course. So you even have to do this mind shift. So imagine you're using today transaction when you want to handle multiple operations in an atomic way. So basically, you wrap all these 1, 2, 3, 4, 5, 6 operations in one time, and if something goes wrong, you roll back immediately to what it was before. So we should change this kind of approach. So let's imagine we have module A operation and module B operation. We should be, for example, yes, we can use, for example, transaction inside the same functional array if they're sharing the same database, but we should split in different operations. Because one of the DDD principle, for example, is that you should follow what happens in the reality. This is a kind of corollary of the DDD. So basically, in the real life, you don't have transactions. But you can roll back what you did by reverting. So basically, it's more like what happens with Git when you do some commit. You make one commit, and you can roll back one commit or revert one commit, basically.
Thank you. Yes, thank you, Riccardo. One more round of applause. Thank you.